this US candy production assignment that we had talked about. So what I did here is basically, excuse me, you know, I did the overall mean, variance, and standard deviation for the entire table. So that goes from, you know, 1972 all the way to 2017. So you can see, you know, that mean comes out to be 100.7. And, you know, we were rounding these to one decimal places because I believe it was Isabel who had asked the question of what kind of rounding we wanted. To remember, the rounding is you always do one decimal place more than your raw data. And since our raw data is all whole numbers, we were going to have one decimal place in our calculation. So if you guys did not have the proper rounding, you did actually lose points on your assignment. And so you can see for the entire table going from 1972 to 2017, our mean for the entire data comes out to be 100.7. The variance for the data comes out to be 325.3, and you will see we have a standard deviation of 18.0. So this is for the entire table. And then you can see the breakdown for each of these years. So going from, again, 1972 to 2017. So that is for all the individual years over here. And, you know, I had asked you guys to show me what formula you had used. And some of you did show me that, some of you did not. So what happens is, because, you know, if you're doing for just a single year, so whatever years were assigned to you, if you're doing it for a single year, remember that's your sample size, right? That's not your population. So the formula you used, especially for variance and standard deviation, is where it would be crucial, because, you know, calculating the mean is the same no matter what. So you had to use a formula where your denominator had the n-1 formula in it. And remember, I had told you you can use the standard formula or the alternative shortcut method. So either one of those would have been fine. But since some of you did not identify which formula you used, again, you know, it was hard for me to verify your calculations. So again, like I said, for each individual year, you had to use the sample variance and sample standard deviation, because these would be considered as sample out of our population. And then I had also asked you to find the 3-year mean, variance, and standard deviation also. So you will actually see that is going to be this bottom table over here for, you know, in groups of groupings of 3 years. And then, you know, you basically had to do a comparison between each individual year and the 3-year total. So just as an example, let's do, I guess I'll just use this last one over here. So let's take a look at these 3 years, 2014 to 2016. And then you can actually see what this 3-year average is going to be. So you can see how we are going from 2014, 15, and 16. Your mean is increasing from 104.2 to 110.8 as you go from one year to the next. But then as we go from 2015 to 2016, you will see that your mean goes down a little, because now you're just at 108.5. When you look at the standard deviation for, again, these 3 individual years, you will see the standard deviation for 2014 is 14.7. For 2015, the standard deviation goes down to 9.8. And for 2016, it goes down to 6.0. So this actually tells us that the data for 2014 is much more varied than the data for 2016, because, you know, remember when your variance is small, that means the data does not vary as much. It's not as spread out, as dispersed. So these were the kind of things that I was looking for when you were discussing your conclusion. And not many of you really got very detailed in your conclusion. Some of you just went with the very bare minimum, and some of you had at least a little bit of an insight. You gave me a little bit of a good explanation. So based on that, you got points for your conclusion. And then, of course, if you look at the 3-year total calculation over here, you will see for the 2014 to 2016, our mean came out to be 107.9, which is kind of right in the middle of that range of the mean you see from 214 to 216 individually. Your standard deviation in this case comes out to be 10.8. So, of course, this data is a little bit more varied than our 2015 and 2016 data. So the idea was, you had to do your comparison based on mean, variance, and standard deviation. And, again, like I said, if you did not have the proper rounding, you lost a point, you lost partial points on that. And if your calculations were really off, they were not even in the neighborhood of what the number should have been, then again, you ended up losing points, or you did not get any points, depending on, what answer you had come up with. Now, some of you actually use the population variance and population standard deviation calculation when you did the 3-year total. So when you did 2014, 2015, and 2016 together. And that's okay if you consider that as your population, and then each individual year as your sample size. But honestly, the entire 1972 to 2017, that would have been our population. So even when you did that 3-year calculation together, technically that should still be considered as a sample, right? Because you were not doing the entire data set itself. And so that's why I was really interested in seeing what calculations you used. And then one of you actually ended up using sample variance calculation on, like if you had the year 2014, then for variance, you use the sample variance formula. But then when you calculated the standard deviation, for the standard deviation, you use the population standard deviation formula. So you can do that. If you're looking at one tiny sample size, then both calculations have to come from the sample variance and sample standard deviation. So within the same data, you cannot use sample and population calculations, because then that doesn't make sense. So you have to be very precise in these calculations. And so those were part of the things that I was looking for. So just kind of keep in mind that these grades that you got will be added to your homework and quiz and other projects grade that we have together. So this assignment will become a part of that grade. It's not going to count towards your chapter exams or final exams. So these grades are going to go along with your homework and quizzes and other assignments category that we have. So anybody have questions on this assignment and what I sent you back? Okay. And if you want to, talk to me individually, feel free to send me an email and we can try and find a time to talk, or, we can talk just through email, whatever you're comfortable with. All right, guys, so let's move on to our next handout over here. And actually, let me show you where you can find this. Actually, it's not under content. If you go under assignments in your D2L course shell, and I had shown this to you last time, you will see that I have changed the due date. Let me see if it will let me move to a student mode. Okay, so go under assignments. And then under assignments, you will see for the sampling methods and bias homework, you have two different handouts over here. So one of this is going to be a worksheet, which is what you and I are going to be working on it together. And then the second one is the homework. And so that's going to be the second one over here is what you guys will be working on for your homework, and you will be turning it in, and you will see the deadline I have set is for midnight tonight. It shows up as November 13th at 12 a.m., but that's technically, midnight tonight. So just make sure you turn in your assignment before, um, this day ends. Don't wait till the last minute, guys, because you just never know, what kind of technical problems you might run into, internet going down, laptop not working, and any of those. So I would say get it completed as soon as you can and just, submit it from here. So just like you had submitted your US candy production assignment, once you finish your homework assignment, just submit it like you did for the candy production. But keep in mind, the first one is the worksheet, which is what you and I are working on right now. And the second one is the homework, and this is the one you will be sending to me for your homework. Okay, so let's go ahead, take a look at our worksheet over here. Let's make this a little bit bigger. So, we're talking about sampling methods. Now, when you're talking about sampling methods, basically the idea is if, you decided I am going to conduct a study, then it can be anything simple. Let's use the example of how much water do people drink in a day? How many gallons and ounces of water do people drink in a day? So now, obviously, we're not going to survey everybody, who drinks water, which would be pretty much any human being. So you would then have to decide, what sample do I want? Do you just want to talk to your family and friends? Do you want to talk to your classmates? You want to talk to people you work with? So, you will try and identify, or do you just want to go, stand outside a grocery store or a mall? Obviously we're not talking in terms of COVID times, but just normally, you would go maybe talk to strangers. So how would you collect your data, and how would you consider to gather your sample for this study? So that's kind of what we're talking about here, is different techniques for collecting your sample to perform a study. So we're starting off with a random sampling technique over here. They're saying this is a sample in which all members of the population have an equal chance of being selected. Subjects are selected by random numbers. So, a lot of times what they will do is, let's say you have thought about using your family, your friends, co-workers, classmates, and, maybe another group of people like just people, maybe customers or whoever you deal with on a regular basis. So now you have this pool of, let's say, 100 people, but again, you don't want to talk to all 100 of them. So the idea of a random sampling is you will just assign everybody a number. So if you have 100 people, you can say, okay, I'm going to assign this person number 1, number 2, number 3, number 4. And then you can either use a random table, or you can use a random number generator. So I don't know if you guys are familiar with this website called random.org. And it actually gives you a lot of different calculators over here, but we are interested in a random number generator. So we don't really want integers in our numbers. Oh, where's my random numbers? Okay, so it looks like they've actually changed their menu options a little bit. For now, I'll just go with integer generators. Okay, so let's say I want to generate, I don't know, maybe 30. So let's say we have a group of 100 people, but we're only going to talk to 30 out of them. So we want to go from numbers 1 to 100. Now we do have a total of 100 people. So your values are going to go from 1 to 100, but we are only looking for 30 people to be in our, sample size. So you click on that and these are the numbers. So basically the idea is whoever was assigned these numbers would be part of your population. But as you will notice, there's actually a couple repetitions happening over here. So, obviously then we don't want repetitions, we want unique answers. So you can go back and trying to see, I kind of miss my just simple number generator because you could tell it to not have repetitions in there. Anyway, so you can kind of play around with this if you like, but that's kind of the idea of using a random number generator, because then all those people are the ones that you would use as part of your sample. And when they're talking about everybody has an equal chance of being selected, because then what happens is you have no control over who you selected, right? Because now you're just taking the numbers that came up through this random number generator, and those are the people that you are going to ask, how many gallons of water do you drink in a day. So just as an example, they are saying the subscribers to a gym membership are numbered. So let's say if there are 5,000 subscribers, we would number them from 1, 2, 3, 4, 5, all the way to 5,000. And then, like I said, you would select sample by using random numbers. So, whichever numbers came out to be, those would be the people we would do our little survey on. Systematic, as the name suggests, we're saying the sample is obtained by picking every nth member of the population after they have been, after the first member is randomly selected from, 1 through n. So again, if we think about our group of 100 people that we know, and let's say we just arrange them again from numbers 1 to 100. So you can randomly, and again, you can do a random number generator for that also. So let's say we actually just want one number, just one random number from this group of 1 to 100. So if we click on get numbers, it gives us 65. So the 65th person can be the first person we select. And then, you can kind of go along with, okay, so I'm going to choose well, depends on how many people do you want in your sample size. If you want a total of 30 people, then, of course, we would have to do 100 divided by 30, which will give us what, a decimal answer? Because that would be 10 divided by 3. So I think it comes out to be 3.33333 repeating. So basically what you can do is you can say, I'm going to select every third person from the group. So start with the 65th person, and then you start counting every third person after that. And if you need to circle back from the beginning, you can, and you keep going till you get that total sample size of 30 people. So basically in systematic, like we're saying, you will basically select every third member or every fifth member, every 10th member, depending on what your population is and what your sample size you're looking for. So in this example, you can see they're talking about every 300th box of cereal is picked. The numbers of ounces is measured to check for the accuracy of the filling machines. So basically in this case, every 300 box will now become part of our sample, because that's the box they're going to weigh to see how accurately those machines are, filling the cereal. So that's our second method. We have stratified sampling technique. And in this one, we're basically talking about the sample is obtained by dividing the population into subgroups based on some characteristic. And then your subjects are selected at random from each subgroup. So just as a basic example, we're talking about dividing our group by gender, and then you are selecting 5 people again, randomly. So, again, you don't look at preferences. You would, again, for each group that has been subdivided into genders, you would still need to randomly select members from each group. So, they're talking about gender, but let's say if we're talking about our how much water people drink example, you can break it down by age group, right? So different age groups will give you how many ever members, and then maybe in our case, we would say 2 members from each age group you are going to select randomly. So that's kind of how the stratified system works. So you're breaking them down based on some characteristic and then selecting people from each of those subgroups that we have. Now cluster, and sometimes stratified and cluster can seem like they are almost the same, but the difference is in stratified, we select members from each subgroup. In a cluster, you actually take everybody who's part of the cluster. So here we're saying a cluster is a sample that is obtained by dividing, again, people into subgroups. But in this case, one or more clusters are selected at random and all members of the cluster are selected. So they're talking about, our example here is a group of students are divided into freshman, sophomore, junior, or senior. And then basically, since we are talking about selecting a cluster, all the students who are into the junior subgroup, you're going to take all of them and ask them to answer a poll. If we go back to comparing stratified and cluster sampling, let's say we divided our population into age groups, right? We went from maybe, well, I would say 1 year to 10 years because, babies not really going to give you an answer on 0. So if you want to go that young, or you can do, 11 years old to 20 years old, 21 years old to 30 years old, 31 to 40. So then with stratified, like I said, from each subgroup, you would be randomly selecting a member. Cluster means you would be taking everybody. So let's say if we randomly selected the age group 21 to 30, that means everybody who falls in that age group is going to become a part of our sample. So that means you're selecting the whole entire cluster as opposed to just selecting some members from all of the subgroups. So here they're, talking about the junior class. So everybody who's in the junior class will be selected to answer the poll, which means we do not have anybody who's a freshman. We do not have anybody who's a sophomore and no one who's a senior. Those people are not going to be in your sample because we took the entire junior class and only use them as our sample. Convenience, as the name suggests, is basically the most easily obtained sample that you can get. So they're talking about, example here could be viewers of a nightly news program are asked to call in and express their view on a topic. So think about this. If these people are watching this nightly news program, more than likely they are regular watchers, right? They probably watch this every night. And if they are being asked to call in, which means people are volunteering themselves, right? They're saying, oh yeah, I want to call in. I want to give an opinion on, whatever the topic may be for that day and express their view. So this is convenient sampling because it's not random. It's not following any of the other techniques. And usually, people who watch the show probably agree, with what the host and everyone is talking about. So their view is going to be very much in line with probably what the news reporters are talking about. You may have somebody who may be of a completely opposing view and they may call in, but most of the times, you're going to see people who favor what they're talking about. So let's take a look at these examples over here and let's try and decide out of these 5 different sampling methods, which one do they have? So the first one here is talking about a gift certificate is given away at a home improvement store. Customers fill out a form and the form is placed in a bin. a blindfolded person picks a form from the bin. And I'm sure you've seen this happen at, different types of stores. So what do you think this would be? Random, systematic, stratified, cluster, or convenience? Okay, so it looks like Isabel, Markley, Molly, Logan, you guys are going with random. Logan, Ethan, Lisbeth. Okay, so that seems to be the general consensus over here. And it does sound a pretty good example for random sampling because they are talking about just filling out this little form, putting it in a bin, and a blindfolded person is picking it up. So let me see if it will let me write this over here. There we go. Random. Okay, number 2 is talking about a state is divided into counties. All addresses are selected from 3 random counties for a water survey. So of course we know states are already divided in counties, and they're talking about all addresses are selected from 3 random counties for a water survey. So again, will this be random, systematic, stratified, cluster, or convenience? Okay, let's see. Burgundy, you're talking about cluster. All right, let's go take a look at the definition again for cluster. So cluster is talking about a sample is obtained by dividing the population into subgroups. So those would be our counties, as the subgroups. One or more clusters are selected and all members of the cluster are used. And they are specifically telling us all addresses are selected from these 3 random counties. So yeah, very good, Burgundy. This will be an example for cluster sampling. Does that make sense, guys? Yeah? Okay, what do you think about number 3 here? They're saying every 45th TV coming off the assembly line is checked for defects. Random, systematic, stratified, cluster, convenience. Okay, let's see, Isabel, Burgundy, Markley, you guys are going with systematic. All right, let's take a look at systematic over here. They're saying sample obtained by picking every nth member of the population after the first member is randomly selected. So yeah, very good, because they are telling us this is the every 45th TV coming off the assembly line. So very nice. Systematic for this one. Okay, number 4, people leaving a grocery store are asked how much money they spent on produce. So people leaving a grocery store are being asked how much they spent on produce. So random, systematic, stratified, cluster, convenience. Okay, so Burgundy, you are saying random. Isabel, you are saying convenience. Okay, Burgundy, you're changing it to convenience then? Okay, Markley, you are also saying convenience. Yeah, because, that's honestly the easiest way to pick your sample, and that's what they're talking about. Use subjects that are convenient or easily obtained. And, that's probably okay if you just want to get a general idea, but, convenient sampling, honestly, is not the best sampling method to use, because it will give you a lot of biased results, and we'll be talking about biases here in a minute. So very nice. This guy is convenience sampling method. And let's see, the last one is talking about a group of students are classified according to age. A random sample from each group are asked how many credits they signed up for in the coming semester. So we're classifying a group of students by age, and then they are talking about a random sample from each group are asked, how many credits they are taking for the next semester. Okay, Molly, you are talking about stratified. So let's take a look at stratified here. This one is saying a sample is obtained by dividing the population into subgroups. So we're breaking them down by age. And then subjects are selected at random from each subgroup, and that's the important part. And they are telling us that a random sample from each group are asked how many credits they are taking. So very nice. This guy is going to be stratified. Did any of you have question on this one? Okay. So the next thing, and that's another thing that happens a lot with statistics. And, we had talked about biases that can happen or misuses when we were talking about average. If you remember, when we use the word average, we don't know if they use the arithmetic mean calculation or did they use median, mode or mid-range. So we don't know when they use the word average, what kind of calculation they're talking about. And, we saw with some examples, all four of those numbers can be completely different from each other. So let's take a look at some other forms of biases also. So we're talking about people, businesses, advertising firms may misuse statistics to their own advantage. So statements should be examined carefully. Ask yourself, was the sample unbiased? Was the sample large enough? And we talked about that margin of error last time, where we were talking about how sometimes if you have a smaller sample size, your margin of error can be large. So to make your margin of error small, we need to go for a large sample size. So same thing, with statements that are being thrown at you or different studies, we kind of have to think about, is the sample unbiased? Is the sample going to be large enough to give us good data? Can the statement be interpreted in more than one way? Look for vague words being used. Average is definitely one of them. Largest, best. And those can actually, by using words like these also, subconsciously they are taking the reader in a particular direction. So again, we have to be very careful about what kind of words are being used. So bias can occur because of the way a question is worded. So here they're talking about in a golf ball advertisement, spring ball and another ball were hit in the same way. Spring ball travels much farther than the other ball. We are supposed to decide spring ball is a better ball because obviously it travels a lot farther. What is not mentioned is the number of times the experiment was performed or what the results were of the previous experiments. So, possible source of biases here could be what was the wind speed, the direction of the wind. No two swings are going to be identical. Did the ball land on a smooth or a rough surface? Because, all of those are going to affect the performance of the ball. So here they're talking about information from research studies is sometimes taken out of context. And they're just talking about, what do you think the bias might be here? Why do you think that these studies might be suspect? So again, you're looking for those vague words. You're thinking about, what bias might be there that they are not explaining, like they're talking about here with the golf ball ad. So the first one here is talking about the average salary of the graduates of the class of 1980 is $32,500. So what do you think might be a bias over here, or why does this sound suspect? What's a possibility? So the average salary of the graduates for the class of 1980 is $32,500. So what do you think might be a bias here? Read the statement again. What do you see? Yeah, they're talking about the graduating class of 1980. So one class is okay. They could be talking about a particular school or something. And again, we don't know that because they didn't give us. Okay, very good. How many are in the class? What else? The word average, very good. Very nice. So yeah, we don't know the sample size of the class because some schools do have a smaller group of students. Some schools are very large, so their graduating class can be very large. So yeah, very nice. Definitely the word average. And what is the sample size? This example always reminds me of the example of the basketball player Michael Jordan. Is from North Carolina. So his graduating class, their average income, yearly income is, six figures. Um, and so they always talk about, how this school is really great. Look at our average income for our graduating students. It's a six-figure salary. But, this is where the idea of outlier comes into play because think about Michael Jordan. He was definitely a great basketball player. He had a lot of endorsements from different companies. So, his income was really in millions and millions of dollars. So even if his classmates had a regular salary for their education and what work they were doing, but because this one person had such a high salary, remember how that average gets pulled towards the higher end, especially the mean, when you are taking all the numbers into consideration, even with the outliers. And that's basically what this school was doing. When they were talking about their average salary, they were obviously taking Michael Jordan's salary as part of that overall calculation, which was increasing the average. So you always have to think about, are there any outliers in there? Like you said, sample size. Well, what does the word average tell us? Well, which calculation did they actually use in this case? All right, very nice, guys. Number two, it is estimated that in a city, there are 27,256 cats. So what do you think might be biased or suspect in this statement? Okay, so you're saying the word estimated, what the population of the city could be. Okay. What else stands out? Now think in terms of the cats themselves. Yeah, what kind of cat? Are they talking about pet owners or are they talking about feral cats, right? Because again, they don't tell us, are these cats just roaming the streets in the city? Are they talking in terms of people who own pets that are cats? So again, not enough information. So they are talking about an estimate. So again, we don't know what exactly do they mean by that. What kind of estimate are they looking at? uh, you know, um, pets, or are they wild? Oh, come on, buddy. There we go. Are they pets? Are they wild cats? And I think one of you also mentioned what was the city population. Because if it's a big metropolitan city, with 10, 15 million people, then how does this ratio of cats work out with them? And again, we don't know what kind of cats these are. Okay, only 3% of men surveyed read Cosmopolitan magazine. Okay, so well, only doesn't really specifically give us a whole lot of concern by itself, but what along with it is concerning. Yeah, how many men were surveyed, right? Because they're talking about only 3% of men surveyed, but then they're not telling us 3% out of how many, right? So we don't know, again, what was the sample size here? Because, you know, if they talk to 10 men and 3 of them read Cosmo, well, that's your 3%. Or did they, you know, talk to 100,000 men and, you know, out of that, they got 3%, because that sample size, again, makes a difference. What else? Can you think of anything else that could create a bias in this statement? Okay, so Isabel, what do you mean by the magazine? In what sense? And if those of you, if you don't read magazines, you know, Cosmopolitan was supposed to be centered towards women, you know, makeup tips and fashion and shoes and that kind of thing. My roommate in college was crazy about this magazine. I honestly don't even know what Cosmo looks like anymore. So that's kind of why. Yeah, because, you know, if they were talking about, because, you know, what I am kind of thinking in terms of where did they actually conduct this survey? Because if they were at a place where, you know, mostly women are buying these magazines, you may have 1, 2, you know, people coming and buying Cosmo who are men. But, you know, if they're going to be, you know, outside, let's say a dress store, you know, kind of like those newspaper stands kind of thing, you know, if it's going to be in an area where women shop more, you're not probably going to see a lot of men, you know, outside those stores. So, you know, also where the survey was conducted can make a difference also. Right. And Molly, and I think, and again, that's another thing you kind of have to think about. Was their intention only to talk to the men? Were they going to get female data also? Because again, you know, obviously in a single statement, we can't find that out either. So yeah, we don't know if they were only interested in the data for men, or were they also looking for female also? Yeah, what kind of target they were going for. Based on a recent male survey, 85% of the respondents favored gun control. So again, think about what kind of bias could be built in with this statement. Okay, very good. Again, sample size, how many respondents were there? Very nice. Who was targeted? What else? Where the survey was taken, how many people? So yeah, location again for where did they actually send the survey? What else? Now they're talking about mail survey, right? Which means this was sent to you by the post. If you're talking about a mail-in survey. So think about this. If they're talking about 85% of the respondents favored gun control, you know, it seems like, and you know, again, we're making an assumption because we don't know anything other than this statement. It is very possible that these surveys were sent to people who probably have let it known that, you know, we favor gun control. So if you're sending a survey to somebody that you know is already on your side, there's a very good chance they would send you the reply back and say, oh yeah, I'm in favor of what you're talking about, right? So this would actually be almost leaning on convenience sampling. Because, you know, if you send the surveys to people who you know are in your favor, you are going to get a favorable answer. Now, if you send this to somebody who does not believe we should have gun control, then, obviously they would say, okay, I'm not agreeing with what you're giving me. So who was the target audience? What was the location, which area they sent it to makes a difference. And then, yeah, again, what was the sample size? They could have literally talked to 20 people and still come up with the same result. Okay, a recent study showed that high school dropouts drink more coffee than students who graduated. Therefore, coffee dulls the brain. Okay, so they're telling you a recent study showed that high school dropouts drink more coffee than people who graduated, and they're saying, therefore, coffee dulls the brain. Yeah, there are no numbers, definitely. What else? So what bias are they creating in this example here, in this statement? Okay, they cannot back up their conclusion, drawing conclusions without evidence. Well, they're talking about their evidence as the study that they did. So they're kind of falling back on this idea of, we did this study and that's our evidence. So, and again, obviously we don't know what that evidence is. So like you said, I think it was Burgundy, they're not really talking about the numbers over here, but think about something else. They're talking about coffee dulls the brain. Are any of you in the habit of waking up in the morning and drinking coffee? Anybody who is so coffee dependent you cannot make it through the day? Well, the same roommate that I was talking about in college, apparently her day does not start till she does not drink coffee. And I'm not a coffee drinker. I drink coffee twice a year, maybe on special occasions. I do not drink coffee a whole lot. But, I have colleagues that I work with. The first thing they do when they get to their office in the morning is turn on their little coffee pots in their offices, which smells amazing. Coffee has a great smell. But yeah, again, I'm just like, wow, how did you even make it from your home to the college? Because, they just cannot do without coffee. So some people can make the argument that coffee stimulates you, right? Because people talk about how it wakes you up in the morning. You kind of need that first cup of coffee to get your day started. So then they can say, well, no, I don't believe that's true. Additionally, they are actually not talking about what could be a reason that the student dropped out of high school, right? There could be many different reasons. They're talking about people who graduated. So think about this. Does that mean every single person who graduated does not drink coffee? And every single person who dropped out of high school drinks coffee? No, right? Because you cannot make those conclusions. So there's actually so many things happening in this one little statement that they have given us here. So there are actually a lot of red flags over here that you have to look for. So basically, there is no correlation between coffee and I don't know, brain function. Now, of course, people can make arguments about caffeine and that sort of thing, but, obviously we're not getting that detail in here. Since most automobile accidents occur within 15 miles of a person's residence, it is safer to make long trips. So they're saying within 15 miles of where a person lives, you will run into the most accidents. So it is safer to make longer trips. So yeah, most, that is definitely a vague word. Because, again, they are not really supporting it with much of numbers over here. Who are they sampling? Okay, so what is the target audience here? Okay, what else? So think about the argument. They are saying it is safer to make long distance trips to avoid accidents. Yeah, what neighborhood they are talking about? Yeah, because they're talking about 15 miles within the person's residence. So yeah, very nice. Are they talking about urban or rural areas? And you know, again, think about this logically. Aren't you at more risk when you're taking longer trips? Because the idea is you are driving long distances, which means you're going to be behind the wheel for a longer time. You have to take into consideration, you know, getting tired. Um, you know, for that matter, we can also talk about distractions, right? Because maybe as soon as you're leaving your home, maybe you are on the phone. You know, maybe trying to call ahead that, hey, I'm on my way, kind of thing, right? Again, the same roommate in college, and I know I keep picking on her, and I'm glad she's not around to know that. She used to literally drive with her knees, and she's like a giant, 6 feet to 6 feet 2 inches tall. So I'm like a dwarf next to her. But she would literally drive with her knees and put her makeup on as she was driving to school. Do not do that. And this is not me endorsing you guys putting on makeup and driving with your knees. So, you know, accidents will happen when you're doing stuff like that behind the wheel. So, there can be so many reasons why accidents are occurring within those 15 miles of a person's residence. You know, people maybe are not watching those stop signs. They just, are driving right through those. So many different things. So again, it's not necessary because long distances can have their own risks also. So just again, kind of make those arguments with yourself, like what about this statement does not seem right. Okay, last one over here. In light of Mayor Smith's recent arrest on moral charges, do you feel that he is doing a good job as mayor? Give a number from 1 to 10, with 1 being a poor job and 10 being a great job. So if somebody presented this question to you, what's the red flag? What's the bias you are noticing in this example? Yeah, because they are already telling you that his recent arrest on moral charges, so they're already throwing the bias in there, right? Because they're like, oh my God, he got arrested for something he did. So what do you think? Obviously, most people, and if they're not, aware of the situation, they'll say, well, he got arrested, and they're saying moral charges, right? They're not even laying out what specific the charges are. So that already creates a bias in your mind, and you're like, yeah, okay, I'm not going to vote for this guy, or I don't think he's doing a great job. So they are, in the question, there is actually an implicit bias when they are including that little recent arrest on moral charges. Yeah, and they're just giving you a very basic scale. Yeah, like you said, it's only going from 1 to 10, not allowing for any reasoning in there either. So yeah, and this is definitely something, they were talking about how in certain advertisements or polls and stuff, they try to misuse data or create this bias. So again, kind of watch out for those types of examples. All right, so these were just examples to kind of show you what things you are looking for. So this is with the bias, and this was your sampling example. Now your homework, this is what your homework handout will look like. So you will see the first 9 questions are going to be on the sampling method. So you read through the examples and see out of these 5, which sampling technique they are using. And then at the bottom, you will have 6 questions where they're asking you to explain why these statements will be suspect. So, put in a good reasoning. Don't give me one-word answers. Give me a statement. Explain to me why you think there's a bias in these statements. So make sure you are identifying the bias and explaining. So do not give me one-word answers. Okay, so again, you will find this handout under assignments when you go to your D2L course shell and just go down to the sampling methods, and it's going to be this second one in your assignments. So any questions on this handout over here, folks? Okay, so remember you have till midnight tonight to send me this completed homework document. Do not wait till the last minute, because if you fail to turn it in, then you will not get a grade on the assignment, okay? So just please don't miss that deadline. Alrighty, guys, so that is actually the end of chapter 4. So again, remember, I have given you till Sunday midnight to finish your chapter 4 assignments. I'll go ahead and open up your exam. I was actually tweaking it yesterday. I was trying to see if I could put a couple of my own questions in there, kind of like this sampling and bias handout problems. But right now it's not doing it the way I want to. So I'm going to play around with it a little bit this afternoon, but I'll have that exam ready for you today. So just please make sure you finish all of your homework. You've got 5 homework sections in there, 90% on the homework section to get to your quiz and the exam. You do not need 90% on the quiz, you know, just whatever best score you can get on the quiz. And then for the exam, 90% on homework sections and 90% on attendance. So if you don't get the password from me, that means you do not meet the attendance requirements. So just kind of keep that in mind. Alrighty, guys, so let's go ahead and look at chapter 5 next. Chapter 5 actually is only 2 small sections. We're only doing 5.1 and 5.2 in chapter 5. So as you can see, we're getting into, you know, some calculations here with financing. And the first one we're starting out with is just simple interest. And you know, you guys might have done these calculations in some other math class, so this may just kind of be a refresher. So just some terms to keep in mind. You know, when we're talking about principal, and you know, sometimes we actually also call it the present value, because that's how much money you are investing today. So, you know, that's the present. Interest is, of course, going to be a dollar amount. How much interest have you actually earned, you know, when you invested your money? So the interest itself is always a dollar amount. You know, of course, principal is also a dollar amount. When we're talking about interest rate, that's your percentage, right? Because that's the percent of interest your money will be earning. So, you know, is it 5%, you know, 10%, 0.1%, which is where, you know, the current interest rates are right now because, you know, of the economy. Then your time or term is basically for how long are you investing the money. So how long are we going to keep the money, you know, in whatever account you are doing. Now, another terminology that they're not talking about here, because, you know, we're right now just focusing on the interest, but is also the terminology of amount, or it is also called the future value. And future value is basically, you know, after the time has passed for however long, you know, 5 years, 10 years, for however long you're keeping the money in your investment account. After that, when you have earned the interest, what will your total amount be at the end of that investment? So that's what's going to be in the future. So that's why we call it the future value, or just as the amount. So they're talking about simple interest is basically the amount of interest which is calculated based on, you know, your percentage for the annual percentage rate on your principal. And it's a very straightforward formula. I is the simple interest which is again a dollar amount on your principal P at an annual simple interest rate of R, and depending on the time, T years equal. So I equals P times R times T, or I equals PRT. You can see in this example here, we're talking about Tom and Betty buy a 2-year CD that pays 5.1% simple interest from their bank for $150,000. So they're talking about many banks pay simple interest on larger CDs and compound interest actually on smaller CDs. So they're talking about investing $150,000. So that's your principal. They're telling us the rate of interest is 5.1%. Always convert your percent to decimals, so that rate becomes 0.051. And they're talking about a 2-year CD, so that means our time is going to be 2 years. Okay, so they're basically asking us to find what the interest dollar amount is going to be. So that's your formula, I equals PRT. Multiply the 150,000 with the rate of interest of 0.051 for 2 years, and at the end of the 2 years, our $1,500,000 will have earned basically $15,300 in interest. So now if you take that interest and add it with your principal, you will get a total of $165,300, at the end of the 2 years. And that, like I said, is your future value. So that CD will be worth, $165,300 2 years from now. And those are one of the safer investments to make, but that also means normally you cannot break a CD if you put it in a 2-year CD. CD normally means cash deposit. And so the idea is, if you break it before the maturity of that term, if you don't wait for those 2 full years, they actually penalize you. So you may have to pay some kind of penalty fees for that. But if you wait till those 2 years have passed, then, of course, you will get the full dollar amount, whatever that comes out to be. So just to introduce a new formula over here, you add your principal plus interest to get your future value. Now remember, our interest formula is PRT. So what you can actually do is take this common P outside, and from the first one where you had that single P, since we took the P outside, we put this one as a placeholder. And then from PRT, again, that P goes outside. So you're just left with R and T from the second term. So this actually gives you the formula for your future value. How can you calculate your future value based on simple interest? And honestly, it's just as simple as adding the principal with the interest. So they're just talking about how we use capital letters when you're actually talking about the dollar amounts. And we're talking about lowercase letters for, non-dollar amount. So rate, time, those are not going to be in dollars. So for those, you use lowercase letters. Okay, so just continuing our discussion with simple interest, we're talking about one of the more common uses of simple interest is a short-term loan, which is usually a year or less than a year. And basically that requires a single lump sum payment at the end of the term. So lump sum payment is basically the single payment that pays off an entire loan. Now, of course, we're talking about loan, which means you pay the money that you borrowed, but then you also have to pay interest on the money you borrowed. So they're talking about some loans require smaller monthly payments rather than a single lump sum. So either you can pay lump sum, which means the principal that you borrowed plus the interest that money earned. So you pay all of that together at the end of your term, or you can make smaller monthly payments. So again, just as an example, we're looking at Esprit Clothing borrowed $185,000 at 7.25% interest. And you can see that's a really short-term loan because you're going from January 1st to February 8th. So they want to know what would be the future value of the loan, and they're talking about interpreting that future value. So we have the dollar amount we borrowed. We have our rate of interest, convert that into a decimal again. So, think about this. You have 7.25, which is 7.25%. Just move that decimal 2 places to the left, and you end up getting 0.075. Now, in this case, since we are talking about, a short-term loan, we actually need to figure out how many days this loan is being taken out for. So you've got 31 days in January, 28 in February. So they're talking about 31 days in January, and you're actually only using 27 days, because February 28th is your maturity day, which means that's the day you got to pay your money back to whoever you borrowed this money from. So that's why you're adding 31 plus 27. So your time in days is going to be 58 days. But by default, and if you go back and look over here, by default our time is always in years, if you look at right over here. So always in years. So what we have to do is convert these 58 days into year. So there's 365 days in a year, so that's why we're taking 58 divided by 365, and this is how you are converting your time from days into years. And once you have all of these conversions taken care of, then you can just plug it into your future value formula. So our principal is $185,000, 1 plus our rate of interest, 0.0725, and then our time, which is 58 over 365. Just throw all of this into your calculator, and we end up getting a future value rounded to the nearest penny as 187,131.30. And now, of course, we borrowed 185. So you can see you're actually paying an interest of $2,131.30. So this is going to be how much interest we have to pay. And think about that, guys. This is for 2 months, right? I mean, barely for January and February, and you're already paying $2,000 just in interest on top of what you borrowed, because you do have a 7.25% rate of interest over here. And they're just kind of talking about a rough check over here, because since you're adding the interest to the principal, your dollar amount for the future value has to be a little bit larger than what you started out with. Okay, so here they're talking about the reason why we do not use 2 months, where you end up getting 2 months divided by 12 months. So 2 divided by 12 gives you year, because they're talking about if we did, we would get an inaccurate answer, because obviously some months have 31 days, some have only 30 days. February, of course, only has 28 days, or in a leap year, it might have 29 days. So to get a better calculation, an accurate calculation, it's actually better to convert it from days to years instead of going from months to years. So this is, just talking about accuracy. Now, normally what happens is some business institutions will actually use 360 days per year instead of 365 days. And for months, just to kind of keep it even across the board, they will actually say, let's just use 30 days for a month. So they're kind of not taking into consideration the 31 days for some months, or 28 to 29 days for February. They just go with the standard idea of there's 360 days in a year, and there are 30 days in a month. So, some institutions will go about their calculations doing that way. So, if that is something you ever find yourself in a situation, ask them, what kind of numbers do they use when they're calculating these interests and future values. So they're just kind of talking about how you would see just a little bit of a difference in your calculations. And so you can kind of just read about that in this paragraph. But basically, for our purposes in this book, we are going to be looking at 365 days to a year. So you can kind of use the book's calculations when you're going through these examples. So they're talking about a written contract signed between the lender and the borrower is what we call as a loan agreement or a note. The maturity value of the note, or value of the note, is basically how much money you will be paying back. So that's your future value, which is also called the maturity value when you're talking about these notes over here. So let's do an example over here from our textbook. There we go. All that guy comes up. So we'll just do a simple calculation, with the simple interest and the future value. So let's take a look at example 6 over here. And they're just asking us to find the simple interest for the given loan amount. Okay, so find the simple interest, and let's look at number 6 over here. They're telling us we are borrowing $35,037 at 6% for 2 years. So for number 6, they're telling us we are borrowing, so that's our principal, of $35,037. They're telling us the rate of interest is 6%. So 6% will convert that into decimal. And then the time they are telling us is 2 years. So in this case, since your time is already given to us in 2 years, we don't have to change anything on that. So can you tell me first what that 6% as a decimal is going to be? Yeah, very good. Just either divide by 100 or move your decimal 2 places to the left. And they're just asking us to calculate the simple interest in this case. So that is, of course, I equals P times R times T, PRT. So that would be your 35,037 being multiplied with 0.06 and being multiplied with 2. So what do you think this interest will come out to be? Okay, let's see. And yeah, you are rounding it to the nearest cent. So 4,204 and 44. Did anybody else get that same answer? Okay, Isabel. And remember, this is just the interest. This is not your future value. Now, if you wanted to calculate the future value, then remember, this is where you just add your principal with your interest. So then we would have taken our $35,037 and added it with the interest of 4204.44. And what do you think this total would come out to be? Very nice. 39,241 and $44. So this would be your future value. Alrighty, very good. Everybody okay with that? Just a simple, straightforward example. Alrighty, how about, let's change this up a bit. And let's look at number 10 over here. So number 10, I might actually need a little bit more space. Okay, so we are borrowing 5,682. This is borrowed at 11.75%. So what will that be as a decimal? And then it actually looks like our time frame is going to keep changing. So your rate of interest as a decimal, what will we have? 11.75%. Markley already. So 11.75 is of course, 11.75%. So just convert that 3/4 into your decimal and then, either divide by 100 or move your decimal 2 places to the left. So this will end up becoming 0.1175 as your rate of interest. Alrighty. So they are saying we are starting at July 1st and to December 31st of the same year. So how many days are we looking at here? And just look at parts A and B. This one is saying to December 31st, and this one is saying through December 31st. So how will that make a difference between parts A and B? So how many days are we looking at in part A? Burgundy, yeah, very nice. Because when they are saying in part A, July 1st to December 31st, which means December 31st is actually our last day. That is when we'll be paying that loan back. So that means you're actually not counting December 31st in the calculation itself. In part B, when they are saying July 1st through December 31st, that means you are actually going through the day of December 31st, which means you actually end up counting December 31st for that day. So yeah, let's take a look at the breakdown. Burgundy, you've got 183 days for part A. So July has 31 days. What do we have next? August is also 31 days. September is 30 days. October is 31 days. November is 30 days. And then December technically is 31 days, right? But we are not counting the 31st, which means for part A, you are just counting 30 days. So that's what? 1, 2, 3, 4, 5, 6. 6 threes are 18 plus 3 days. So you're getting a total of 183 days. So very nice. Our time here is going to be 183 days. So remember to convert this into years. We end up dividing this by 365. And so that way our time instead of being in days, will actually be in years. And then for part B, you would obviously doing the same calculations, 31, 31, 30, 31, 30. But for December, since they're saying through, you would actually count 31 days, which means the time for part B will actually end up becoming 184 days. So you would be doing 184 divided by 365 for part B. Okay, so that's honestly just the difference between the two calculations. So they're asking us to calculate, and are we still doing simple interest? Yeah, so they're still only asking us to calculate the simple interest here. So for part A, again, you are doing I equals PRT. So what do you think your dollar amount will come out to be for part A? Okay, let's see, 333 and 82. Okay, let me check my math then, because that's a little different. 5682. We're multiplying that by 0.1175. Multiply that by 183 divided by 365. Yeah, so that's not the answer that I came up with. Okay, what about the rest of you? What did you guys come up with? And do not round these fractions, the 183 over 365, 184 over 365. Don't round those numbers, because we do not round till we get to the very last step. So you do not round in the intermediate step. Just wait till the very final answer. So what do we get as our interest rate over here for part A? Okay, let's see, Lisbeth, Burgundy, $334.73. That's exactly right. Yeah, the $334 and rounding it to the nearest cent, which is the second decimal place, 0.73. So how do you think by having that one extra day in part B, how is that going to change our calculation for the interest over here? Because you know everything else is going to stay the same. So by adding that one additional day, how does that change our interest? Okay, let's see, $336.56. It's going up just a little bit, isn't it? $2 and some odd change, or maybe just under $2. Alrighty, very nice. $336.56. So just you can see, even with that little bit of a change of one day, you know, obviously that makes a difference in our interest rate. Questions on this one, guys? So be careful with these, you know, time calculations over here, you know, especially with examples like number 10. Okay, let's do another quick example over here. They're asking us to find the future value for the given present value. And let's look at number 14 over here. So we've got a present value of $172.39, 6% interest, and we're doing this for 700 days. So remember, your future value formula is future value equals principal times 1 plus RT. So using this formula, let me see what dollar amount you come up with for the future value. And again, don't round till you get to the very last step. Okay, let's see, Burgundy. Doesn't that seem like a large number though, the 7,000? You're only like $172.39. That'd be great if we could get that kind of earnings, right? From savings. Unfortunately, that doesn't happen in reality. Okay, so what do you guys have for this guy here? So remember, percents have to be converted to decimal. Time always has to be converted to years. Nobody has an answer? Okay, that definitely seems a lot better than that first answer, right? Okay, so let's take a look. Our dollar amount present value is 172.39. 1 plus our rate, which is actually going to be 0.06, and then you're multiplying that because our time is given to us in days. We would take that 700 and divide it by 365. So yeah, very nice. It looks like you will end up getting 192 point, actually it's 2266 and keeps going. So rounding it to the nearest cent will end up giving us $192 and actually 23 cents. Isn't that, Burgundy? Because you gave me 27. So this is going to be, okay. Yeah, so $192.23. Of course, your other format would be to calculate the interest rate first, I equals PRT, and then add that back into the principal to get your future value. But by using this formula, you can go directly to the future value and you don't have to find the interest separately. And, I definitely prefer using the future value formula, but just to kind of show you how this works. Alrighty. So these were just, basic examples to kind of get us thinking about, how these different calculations would work out. Now, let's take a look at this next example here. So we're actually talking about the US national debt, and it's definitely increased from the number you're seeing here in this example. They're saying in almost every year since 1931, the US federal budget called for deficit spending, which basically means you're spending more than what you are receiving. So because the federal budget is based on the taxes that they get, right? The federal taxes. So the idea is they are actually collecting less in taxes than what they are spending. So that's your deficit spending. They're saying in 2013, the total US federal debt was 17,054 billion. And we paid about $415 billion for interest on that debt. And of course, we're looking at what, trillions now in our US national debt. Honestly, I don't even try to look that number up because it's a very scary number. So that's actually right here on the left hand side. You can see the 27 trillion 241 billion 507 million, and of course the thousands, they are just going to keep growing. So 27 trillion and counting in our US national debt. And you can see just 7 years ago we were just at 17,000 billion. Huge growth. All right, so this example is just talking about, find the simple interest that was paid on the 2013 national debt. So we are talking about calculating the rate, right? Because we know the dollar amount itself was 400 billion, so that's the interest. We know at the time the principal or the national debt itself was 17,000. Oh, do I have a typo in there? I've got 54 here, but looks like it should have been 84. So yeah, looks like I did have a typo in there. And they're just talking for one given year. So you can see how we're using the interest formula, but working backwards. So you start by taking this 17,084 and dividing it into our $415 billion, which is where this is coming from, and that's giving us approximately 2.4% as the rate of interest this national debt is accumulating, right? So you can just kind of see how we are calculating the rate of interest over here. This one here is actually talking about calculating your present value if you know how much money you want in the future. So they're talking about find the amount of money that must be invested now. You are going to get a rate of interest of 5.75%, simple interest again, so that in 2 years' time, that money will grow to $1,000. So we know in the future, we want $1,000 after 2 years have passed. So how much should I invest today? So future value, 1,000. Rate of interest is 5.75. So as a decimal, that's 0.0575. We're leaving the money for 2 years in this investment. So you can see again, using the future value formula, we plug in everything except P, solve what's inside the parentheses, and then whatever this answer comes out to be will be divided into the 1,000. And you can see that is telling us if in 2 years time we want $1,000, then at this given interest rate of 5.75%, we will need to deposit just shy of $900, so $896.86. And in this example, since you are calculating backwards, right, you're finding the present value. that number has to be smaller than your future value. So future value is always going to be larger than the present value because you're adding interest to that. But when you're calculating backwards, your future value is going to be a number smaller than the present value will be smaller than the future value. So that's just kind of what they are talking about here. So they're saying, in example 4, the investment is worth $1,000 in 2 years in the future. So that means today in the present, it will have the same worth of $896.86. And, of course, that is in the present. And so that's why, we call it the present value. This is the investment's present value. And once it has earned interest, it will become your future value. So we'll look at a couple more examples for this next time. We still have the 5.2 section to talk about, which is where we get into compound interest. So that will be kind of interesting to see how a simple interest and compound interest vary in their formulas and their calculations. So just to remind you guys again, you are going to turn in the sampling and the bias homework by midnight tonight. And then Sunday at midnight is when your chapter 4 homework is going to be due. So as soon as I get your exam taken care of, I'll start sending you passwords through email. So just keep in mind, you should have 90% on your homework and 90% on attendance to take your exam. And if you guys have any questions, please let me know. I'll be available today and tomorrow. And I will at least try to check my email over the weekend, but I'll definitely be available today and tomorrow, okay, if you get stuck on anything. All right, everybody, have a great day. Be safe. Good luck with your exam, and I will see you guys on Tuesday morning. So take care, everyone. Be careful. And Cooper, if you want to stay back, I can answer your question that you just sent me. All right, let's take